Hello, Cynthia. How are you?
Hi, Dr. Lynn. I'm doing good.
Good.
I'm sorry about the assignment. I'm almost done with it. I'm at
That's
my
okay.
okay. I'm
Yeah, a couple of the students they emailed me. I guess they were missing the buzzer as well.
oh
So I'm gonna to have a talk with Abraham and Donald um, sometime this week because it looks like some of the kit. I had to double check my list that I sent him,
mhm.
and on the list I had asked for everything, and I think he might be under the assumption that most of the students were taking the Arduino class, which they have all the parts. Um, yeah, so yeah, I'm gonna talk to him about future classes on how they're checking out the equipment and the process, and there was suggestion about a checklist posted. Yeah, so I would implement that in the future classes. So
Okay.
yeah, so I extended the lab due date to like Wednesday this week, I believe.
Yeah, I
And
saw
then
that.
so yeah, just make sure that if you have time you can submit that by Wednesday.
Okay. I did notice that when I went to go pick up the little buzzers, we didn't really have any left. I don't know what happened.
Yeah, well, a lot of the equipment that's there were from, well, I ordered like very large kits that
Uh-huh.
were used, and then they might have pulled out some of the buzzers and they put it, they were either got mixed into the boxes that I brought home,
Hmm.
or something must have happened when they parted out all the kits. I will drop off some more for Abraham week. I gotta let him know that I need to 3D print something.
Okay.
Um, but yeah, so thanks for letting me know. I'll drop off some extra ones for him, and they can actually order, but it does take at least a month to get the district to approve the order.
Oh,
Um,
I see.
yeah, just the process is very lengthy and it can be frustrating. Like I ordered something in December and it came like a month ago. So, and
Wow.
we kind of missed the boat for the IoT class, which is the class after this one.
Yeah.
Yeah, a bunch of Google boards came, and like I was assumed that it wasn't there, and so yeah, just COVID restriction is also difficult because we're not able to access the warehouse and stuff like that. But hi
Um,
everyone, I think we're gonna start in about a minute, so just check out the assignment. We're just gonna do two short things today, and then I'll walk you through two short things tomorrow. But out of the four assignment, you're only gonna be required to do three, um, or four exercises. You're gonna do three out of four. I'm cutting back a little bit. I know I've been giving a lot of stuff, but it's just 2 weeks, and I want you to be exposed to different areas of the microboard. So that way you can do some stuff on your own if you need to. But yeah, so and then we'll talk about what we need to do for the lab this week, and we'll wrap up the second week to finish the course. Okay. How's everybody doing? Let me switch camera.
Professor, I have a question.
Sure.
Um, for the assignment, this is a capacitor. Does it matter what voltage or?
Yeah, no. You can just use the one that came with the Arduino kit will be fine. It's like a little round black one, but you might find other ones
Oh, it came
that
with
are
one?
available.
Oh,
Yeah. So if you look at the Arduino kit, the bag that has all the electronic components, there are a bunch of capacitors in there. I think they also included the temperature sensor in there that I had asked, but I wasn't sure if everybody has it. I was going back and forth on like many different exercises just to give you the basic, because some students didn't take the Arduino course, and they were not given all the equipment that I requested. I went back to my checklist. So to answer your question, you can use any capacitor. The
Oh,
ones with the Arduino kit's fine.
okay. I didn't even look into the bags. I just picked one that I had in my.
Yeah, if you already have one, you can probably use that one. Most of the ones that you can buy individually is they're lower voltage anyway. So
Okay, all right. Just wanted to make sure. Thank you.
yeah, no problem. Okay, welcome back. It's 2:01 on my computer clock. So I'm gonna go ahead and get started. This is the second week of Raspberry Pi in this course, and after this week we will wrap up the course. So you will be receiving a batch from Incredible via email. So it's going to send you an email once I submit the list. And so if you completed all the activities that's required to obtain the student learning outcome based on my assessment, you will get a batch. And then for if you move on to the third class, when you finish the third class, you will get a certificate. And then I will also post how you can get the actual verification from RCCD for the non-credit certificate. It does take up to 90 days. Right now, they are implementing a new or they're testing a new system for non credit courses, which is going to be separate from your web advisor eventually. So there's some changes that's happening. And so, I will post some information on who you need to contact to obtain your certificate. Okay. But for your course, when you complete the course, you get a batch, and that batch is through a credible. We also just acquired Bachelor Pro with Moreno Valley College. I haven't fully set that up with Canvas yet. I hope to do so in August for my upcoming classes. So I don't give batches to all my classes. I think for the specialized classes with specific skills for the workforce, I normally would. For the more computer science transfer courses, sometimes I don't give those. But I should consider going back and resetting everybody badges just to be fair. But anyway, so let's talk about what we're going to be doing this week. So you have a clear understanding. And I did have some fixes in the assignment today, and I'll talk about that only because I was working out some of the fixes just to make sure that you're capable of doing your exercises. Okay. Oh, sorry. Let me unshare real quick. And let me get to. So if you check out your Canvas, you can take a look at week 2. We are doing various things today, so I want to introduce you to sensor, just in case if you want to work on it later. These microboards would be only effective if you understand how to work with sensors, so that way you can build your IoT devices. And the concept is really going to be carried through across different microboards. So if you understand the amount of voltage that's needed, how you would connect it, you would have positive, negative, and a data cable that will be connected, so you can understand how that will work. Okay. So let me share screen real quick. So, see, I always default to that. So we are going to work on sensors this week. Um, the presentation that you see that I post there is really for the lab. We are going to do a little bit of music coding. It's pretty fun. So you do have an option to select your exercises to do for the assignment and the lab. In the assignment, you will find that there are 4 exercises, A, B, C, D, and you can choose to do 3. The reason why I do that is really, sometimes some sensors are more intriguing to students than other. And then also the parts that you have, I consider that. There are some, some of you don't have, the capacitor, maybe some of you might not have all the equipment that we need. And so just to really save you some time, I cut it down to 3 exercises instead of 4. So today I'm going to walk you through 2. Tomorrow I'm going to walk you through 2, and you can choose to do, and they're really short. Except for the LCD one is a little longer, but you don't have to do that one if you prefer not to use LCD, but LCD can be pretty cool and fun. And then we are going to be mostly doing programming projects in our Pi itself instead of using the circuits in the lab. And so you do have an option to do Minecraft if you want to do Minecraft, if you want to do Sonic Pi, to use synthesizer to make your own song, beats, things like that. So I'm going to walk you through the exercises also for the lab. And then there are options for you to do web development, and then I threw in their graphical user interface because most of the IoT device, it would be a lot more useful if the user can interact with it. So it teaches you how to put together a GUI in Python, and then you can host it onto your web server and make it a fully web app. In the past, we used a traditional library, but now you have a lot of different new libraries. They're updated libraries every day. So it's really helpful if you read the documentation, and I'll show you how you can access that. Okay, good. All right. So just keep in mind that the Minecraft one, the version that's pre-installed in your Raspberry Pi or when you pull it for your Raspberry Pi is not the latest version. So sometimes certain things on there looks older, but I have tested mostly all the bricks, all the blocks, like except for the TNT one. In the past, I had my student tested the TNT one and they said it wasn't working, but I think the new library that they have is actually is good. I think that maybe the students, they didn't put in the functions correctly, um, but I have so yeah, it is Minecraft Pi. So you do have options with the lab if you do check it out. I posted everything already, and if you want to do the extra credit course survey, you can. That 20 points can put into something that you missed on the quiz, or maybe one of the assignments that you didn't get to finish. Things like that can be weighted toward those. So when I look at your grade at the end before I post it, I normally go through individual student, and then whichever area that's needed, then I throw in some of the extra credit points to kind of lift up your grade. And so you know mostly non-credits classes and students grade is generally it's pass or no pass, but recently they started doing um okay, I missed the quiz and put on Raspberry Pi as the option, but did not see all the above as the answer. Okay. Well, if you miss a couple of things, if you do the course survey, your feedback is important to me because the next round for this course is going to help the students that are taking them. And then I continue to redesign my courses. So I saw that some of you wanted more Arduino courses. So I will propose that with the department and see if faculty will vote on it. It's unanimous and it's very democratic in the public school community college. So and if they decided that there needs to be more, then I will go ahead and write additional more advanced Arduino and Raspberry Pi courses. So okay. Yeah, I mean, it's really depends on the person. Actually, some people prefer Raspberry Pi more than Arduino. Some people they like Arduino, but I really think that if you want to get in depth with microcontroller and electronics, you can dive a little deeper with Arduino, understanding how to program it a little bit better. There are tons of different sensors that you can use. Sensor kits are generally fairly cheap, so you can buy like different sensors and you can adapt and learn how to program them. And for those of you who are in computer engineering, computer science, that's going to help you in some of the upper division courses, because really understanding the basic foundation of how things are put together, like how computer components and things like that is going to help. Okay. Okay. The new Arduino, if you're looking at some of the new Arduino boards, they come with Wi-Fi. The only downside is that you don't have a full OS with Arduino. but it's really aimed as to use for specific purpose as a microcontroller instead of an embedded system like Raspberry Pi. Okay, all right, so let's get started. I'm gonna go ahead and stop share real quick, and then I'm gonna switch video camera. So for this week, what we're gonna be doing is we are gonna work with sensor first. So just to give you a little bit of foundation, and for those of you who took the Arduino class, this might be a little bit of a review material. And I hope that, the review will jog your memory, and so it will stick eventually, right? So we are gonna start with photoresistors, and photoresistors are really cool. Whenever you look at solar panel or like security lights or things that would be light sensitive. So for example, if you have a porch light that you have a little adapter on your porch light that turns on when it gets dark, that use a photoresistor or photo dependent resistor, which use light. It's a light sensor. Um, or if you're looking at solar panel, they use different type of photoresistors there. Could be for industrial use, but we wanted to really get to the basic and understand a little bit. So for photosensor, there are two types of input and output that we mainly deal with when we work with sensor in general. And for photoresistors, we're looking at analog signal and digital signal, right? So could be an input that will be analog when we talk about sound and things before, but in the same concept. And when you're looking at embedded system like your smartphones, it has a lot of the sensors that are already built into the actual board itself. So for example, like when you're using your smartphone to on speakerphone, or when you're playing music, you're really outputting sound, which is analog waves, right? Analog signal through your speaker. And in order for that speaker to work, which is different than your buzzer, your piezo, is that it has an amplifier. And an amplifier, I don't know if you ever open up an older smartphone board and look at it. I'm always curious about electronics, especially computing systems. So I always like to open up things and see how it works, or sometimes I break things and then see if I can fix it. Um, so it's a good way for me to really learn and to go in depth with things. But if you ever explore a smartphone board, you would find that there will be a chip that is integrated for amplification, and it uses that chip to really control the power sources that's coming from your phone battery. So like when you're plugging in your USB to charge your battery, that battery is then replenished, and then it would use that power source to be able to distribute to the rest of your chips on that particular board. So we see that we would also use things that will be digital, like text messages, email. A lot of all our communication type of environment or interface is going to be really incorporating on the digital end. So here it talks a little bit about the electronic background for digital and analog input and output. So for your digital I/O, whether it's from your keyboard or from when you speak into your phone to tell it a command, or when you play music, you would see that on the digital end, you would find that it would be zero and ones. And we know this, right? The computer sees everything in binary, zero and one. And so therefore, Raspberry Pi is a computing system. It's an embedded system, so it is able to receive digital input and output. So it sees also convert all your data into zero and ones. Um, so on the electrical signal, we would see how much volt is it going to give the system, right? How much volt is going to be on, or how much volt is going to be off. So close to about 1 volt. So when you're looking at like a little bit under 2, 1.8 is where it would be considered off. A lot of people think it's 0 volt, but it's not. It's actually 1.8. And then anything that's above 1.8 it would be considered on. So how does it know that? Well, if it's receiving more than 1.8 volts, then it would know that that signal is going to be on. So if you have between 0 volt to 1.8 volt, that's going to be considered off. It's not completely 0 volt, okay? Now, when you work with Raspberry Pi, if you look at the GPIO, you have a connection that's 3.3 volt and then a couple others that are 5 volts, right? And 5 volts are usually used for components that require more power. But most of the time when we're working with like LEDs or like even photoresistor, we can say that it's safe to go with 3.3 volts. So when it receives like anything higher than 1.8, then it would know that it will be on. So when we give it a 3.3, that means that we would give it enough voltage so that way it can turn on, right? So when you're looking at the ranges for the analog, you're going to see waves like this, and it's not going to be consistent throughout. When you look at your output today in idle, in shell, you're going to see that it's going to range, right? Because light waves is not going to be always the same. um, Sound is not always going to be the same. Sometime loud, sometime lower in volume. So you're going to see waves like this. And then on the digital side, you're going to see it's going to be pretty straightforward. It's going to be either it's on or it's going to be off, right? But again, when we're looking at electrical side, we have to know that it's going to be the 1.8 is going to be the mark. Okay? Any question regarding analog and digital? Okay. So keep in mind that embedded systems, it has to have some kind of converter. It's going to have to convert analog to digital and then digital to analog. Your phone does that. Your computer does that, right? If you're looking at industrial embedded system, they do that. So that's an elevated area in what you see in how we are handling, right, the type of signal that we're using. And so that's really aimed toward what our objectives as human, how we use our system. Um, so in this exercise, you are going to use a capacitor, and it's exactly like the picture that you see there. If you took the Arduino class, you receive a bag of electronics, and you will find a couple of them in there. Okay, you will find other type of resistors and switches. But let me pull one out. They are round. It looks like a tube at the top. And then they have two legs. And you do see that it has one leg that's shorter than the other. Okay. So if you ever open up a computer desktop, if you look at a motherboard, you're going to find capacitors all around the motherboard. And from this week, I hope that you will be able to understand the very basic of what capacitor is, what it's designed to do. I think a lot of the times, many people use computer system without really knowing the details on how they function, what kind of components that's integrated onto the, as part of the chipset or the board, and then what the things are, right? Um, so capacitor, think of it like little power cell, right? Like what they do is they just store power and they would then charge it up, right? Think of them like small little batteries, kind of. Okay. So they would charge slowly and then they would provide resistance. So they are resistors themselves, and they would be able to give, right, small increment of power to the proper components. This is why when you look at your motherboard, you see different capacitors on there. I don't know if you heard at the beginning, David asked what voltage capacitor are you using. Yes, they are varied in the voltage size. So and then the ones that you're receiving in your package is going to be very minimal. Okay, it didn't list the exact ones, But I'm sure that you can probably find the information online as well on what they are, the size of it anyway. So capacitors are polarized just like how your LEDs are. That means that they have two legs that are not equal in length, right? One is going to be longer than the other. So if you look at the capacitor, okay, and then like this one, it also have the label for what kind it is. So it tells you the volts right here, okay? But keep in mind that not all of them are labeled. So you might see some motherboard company, they will not have the label on there. And they would have the color code. However, some are blue, some are black, some are different color. Now capacitors, they do go bad. Um, I started out as a technician, a field technician when I finished school. Um, and I used to troubleshoot computers a lot. That was my job. So, and whenever I open up a computer, like an older computer, and when I look at the motherboard, um, I would find sometime residue around the capacitor, or sometime you would see them swelling, just like how battery swells. So that means that capacitors are going bad, and that can cause your motherboard to go bad. And so if you think about electrical boards, or boards like microboards like these, whenever you see incorporation of capacitor, you know what they're designed to do. And when you start to see residue like brown residue or gray residue around them, that means that they are going to expire. Okay. Um, you can replace capacitor on on the motherboard. However, you have to be able to find the ones that is the same, and then you have to remove the capacitor and replace it. And it is really cheaper for us just to buy a new motherboard anyway, than to go through the trouble and putting in the time. But back in the day, that's what people would do, how they replace the components on the motherboard to remove chips and capacitors and things like that on the motherboard. Okay, so keep in mind that the negative leg is the shorter leg, and that should go to your ground connection on Raspberry Pi. Okay, and then sometimes you would see that side, that leg next to it, you would see a negative symbol. Okay, so we would know that the negative leg is going to be the shorter leg. Any question? Okay, no question. All right. Um, the next one I'm going to talk about is going to be your LDR, or your photoresistor. They are also known as light dependent resistors. They are passive components um, that decrease resistance, and it's a way for us to use it to detect light or luminosity. Okay. And so they came up with a way to really measure it using lux, which is amount of light that would, or luminous lights. They used to base that on candle lights, right? So if you wanted to research it, you can probably read more into what would be a lux, right? But just to give you a general idea, your photoresistor would look like this. If you're looking at my camera or the picture, right? And when you look at it, it has the same size leg, right? The legs are equivalent in length. So you, just like your resistors, your general resistors, you can plug it in either way. On the top, it is flat and it is oval, and it has like little wiggly sign or wiggly waves, right? Um, but they also come in another flavor. Um, if you have another kind, let me show you what that looks like. So another one would be polarized. Let me stop share real quick. Okay, I'm gonna hold it to the camera so you can see. They are clear, okay, and they look like an LED with a flat top. Okay, I think I showed you this in Arduino class if you took that class. And then the leg, it is uneven, one shorter and one longer. And then when you see that, you know that they are polarized. Okay, just like how we just talked about the capacitor. Okay, so I found that when I work with these, they're about the same as the other one, but I feel like the other one were more sensitive for me. Um, so you can also use something like this. They look like the LED, but they don't really light up, right? They sense light. Okay. All right. Okay. So here it gives you a little bit more information about photoresistor. So keep in mind that the resistance, its resistance is going to be reduced when it's exposed to more light. So when there's more light, less resistance. Okay. So there's a term for that. It's called photoconductivity. And so when the photoresistor is applied to light sensitive circuits, like for example, your security light outside or around your house, or light activated in the dark kind of environment, um, this is going to be really using what's called the semiconductor for resistance. Okay. So in the dark, it would have high level of resistance, the photoresistor itself. But when it's exposed to light, then it's going to be reduced. And that's how we can measure whether it's light or not. So how does it know when it's nighttime to turn on the light? Well, if there's less light outside, right, you would have higher resistance. So that way it's going to activate, right? It's going to then turn on, right? Based on the circuit, turn on your light, your house light or your porch light, and so on. So now here again, just in iteration, it's going to be very low when you give it a lot of light. Now that would be a little bit harder to sense. So when you're looking at, like, there are going to be some kind of interference in the light. So for example, like right now, I'm sitting in a room that has like natural light that's coming in from the window or my glass door. So then I have some light that's coming into the room. It's not completely dark. So its resistance is going to be reduced. And then when I shine a flashlight on my sensor, you would also see that, there's going to be very small drop in that because it's already sensing light in the room along with the flashlight. Okay, so keep in mind that when you do this activity, sometimes if you're in a room that already has light, when you shine a flashlight on it, you don't see a dramatic drop. But if you truly measure it, you can go into a very dark room or do it at night, and then you're gonna see a huge jump in how it's sensing. And then that way you know that your photoresistor works. Okay. So when we put a capacitor next to it, what that capacitor will do is it will charge your resistor at different speed depending on how light or dark. So think of it like how it's going to be varied in distributing, right? The power or the that's going to be needed for the resistance for that resistor or for that photoresistor. Okay, because it could be light, it could be dark, it could be varied. So we want to use capacitor. Now, another way that you can do this is you can give it a 10K resistor. You can adapt to it, and I added my own drawing on there. So that way, in case you don't have a capacitor, you can use a 10K, just like how we did it in the Arduino class if you took that class. Okay, so this table gives you the comparison in light and dark. So if it's pitch black with no light interference, we would say that will be 0 for the lux up to 10, right? And the mean value would be 5. Very dark, there's a little bit of light, you would have 11, and then dark indoors is 51, dim indoors is 201, normal indoors is 401, and so on. So you can take a look. So if we have a cloudy day, that's going to be about 10,001, and then direct sunlight, that will be about 30,001 approximately, up to 100,000. And so this is how you can also think about what kind of resistor or capacitor you would be able to adapt to your circuit. Okay. Any question? Okay, so there's more to this, right? But you can definitely have resources from the internet to be able to, if you're really interested in this, if you wanted to get into like solar technology and how to really build them. There are people who created Arduino projects for solar. They're great, right? I had started or attempt to start one. Um, wasn't able to finish because I needed more parts that I couldn't get, and so on. Okay, next. Okay, so without the explanation, then you wouldn't know what you're plugging in, right? So my job is to give you the lecture. I know you just want to do the project. You can start it, by reading the description. That's up to you. Okay, so you're gonna need a breadboard, large or small, that's fine. You're gonna need a Raspberry Pi with your power cable. You're gonna need a photoresistor, just like the picture. You are gonna need a capacitor. If you don't have a capacitor, please refer to the diagram for the 10K ohm resistor. You are going to need a male to female jumper wire, not a few, 3 actually. And then you can use your smartphone app for the flashlight, or you can use the regular house flashlight or a light on your desk. That will be fine. Okay. So the way that we put together the circuit is just like how it's drawn. Okay. I'm just going to move to the next diagram so it's easier for you to see. Okay. So the shorter leg is going to be on the right side right here where my cursor is, because it's going to line up with the black wire that's going to go to the ground connection. Okay, that's going to be the shorter leg of the capacitor. And then on the middle, so you want it to line up the long leg with one of the leg for the LDR, the photoresistor. Just make sure that they are together. Okay. And then that jumper wire is going to be following that. Now I plug mine into separate channel, like the ground is here, the data is going to be the next one, and then the power one is going to be last. But that's up to you. You can keep them all in the 3 like that. That's fine. Okay. And so when you're using capacitor, you want to give it 3.3 volts. If you're using 10K ohm resistors, you can give it 5 volts. You can test the 3 volt. I think that should be all right, but yeah, 5 volts would do as well. And then so once you connect everything on your breadboard, then you would use so the male side is going to go here, the female side you're going to plug it into your GPIO pins. Ground, GP4, which is GPIO 7 actually, so there's a correction in the code. And then the 3.3 volts. Any question? Now, if you don't have the capacitor, you can do it like this. So your photoresistor, you can plug it there, and then one of its leg is going to line up with the ground, and then your data is going to be aligned with the other leg before your resistor. Why is that? Because the power is going to come from your Raspberry Pi. It's going to go through the resistor, which then will regulate it, and then it's going to send it to the data cable and then your photoresistor. So your data cable can be in between the 10K ohm resistor and the photoresistor. And then the positive, which is going to give it power from the Raspberry Pi, is going to be here. So think of it like a flow, right? You're going to flow power from here through the resistor to the data and then the photoresistor. Okay. I've seen people use potentiometer as well. So you can also use potentiometer because it is a resistor. And then you just gotta adjust it and program it. Okay. Any question? And on this drawing, I have to use fritzing because Tinkercad doesn't have Raspberry Pi board added to their circuit simulation. So, so if you wanted to draw stuff with microboards, and then Fritzing also have a sister company that they can actually produce electrical boards if you design it, and you can pay for minimal cost. But I'm waiting to purchase microboard printer, which is a form of 3D printer for at iMake Innovation Center. I had put this in for 2 years already. And so if we get additional grant, we'll be able to buy that. So by the time that the next group of classes next year hopefully come around, we'll be able to print some using some traces and then print out an actual boards. One of my cousin, he actually designed his own boards for his IoT device. He has a little startup company. Any question? Okay. So once you plug everything in, then you are going to access your Raspberry Pi. You would plug the power into your Pi, and then I will walk you through the next step using VNC. Oh, it's hold on one second. I gotta reconnect because it's about to time me out. And then if you're using your old connection and it doesn't work, just delete it and create a new connection and then re-authenticate with your username and password. And make sure it's the right IP address. And it looks like I have to do that. Oh, I just tested this. Sorry. Just my network is a little bit laggy right now. It's not connecting my Pi. Okay. So, one second. Okay, well, we're gonna have to make do with screen share. I think for VNC you can change the setting on the Raspberry Pi. Yeah, I did earlier. I tested it fine, and then it, you know, maybe I need to have it because it's timing me out on the network right now. So anyway, I have my second camera. So all right, what we will do is we will zoom it. So when you are ready, after you connect, you can go in and open up idle. So click the Raspberry Pi button, and then you are going to click programming and then open up your Python 3 idle. Okay. And if you want to use the other IDE, you can. Then after you have idle open, enter the code. It's really short. The script is very tiny. Now, if you didn't do the other exercises from last week, if you did not install GPIO 0, you need to do that. Otherwise, it would not work. Okay? But if you have done that already, you can just push update. So I didn't include this step in there because I assumed that you did it, but today I realized that some of you might not. So make sure that you open up terminal and then you would do sudo apt install python 3 GPIO 0. And I put the link for their documentation there. So in the documentation, if you click get started, it shows you how to install it. Okay. Okay. Then in idle, after you install it in terminal, in idle, you're going to put this in. So I'm going to walk you through this script. Okay. So you are going to use GPIO 0 package, which is a library. And we are going to import the specific light sensor because we're using LDR. So in the library, they had written scripts that works with light sensor. Okay. Then we declare LDR as an object. And this object is going to access light sensor for pin. I know that in your document it says 4, but if you plug everything in like the diagram, you need to put GPIO 7. You can check that with your card and it shows GPIO 7 for pin number 4. So whichever GPIO that you plug in, you need to specify the value. You need to pass that value in the parameter here. Okay, that's why there's a comment. It says alter if using a different pin. So we want to put 7. Then we have a while statement. While true, it's going to print LDR value. Okay. So what will happen is when after you run this module, this file, right? You're gonna find that it's gonna give you the shell and it's gonna print the value. Now, if it's outputting 0.0, that means that you're plugging into a different pin than what you have specified in your script. Okay, so check your circuit connection. And then if everything's correct, check your code, right? Hardware and then software. We always want to troubleshoot. Let me see if I'm able to go share screen on my Raspberry Pi. I know it's going to be a little slow on the Pi side, okay? All right. So if you're looking at my camera, I have it connected here. And then there's my circuit. And then okay, give me 1 second. So your output is going to be something like this. Okay, then you are going to take a flashlight and then you're going to shine on it. You see how it drops to like 0.6 on my screen, and then it's not going to be like 100% consistent. And so you can test it, but you should see some kind of value showing after you have saved the file and run it. So after I have had my code like this, I'm going to go File, Save As, and then I just call it ldr.py. You can save it to your home directory under Pi. Okay, I'm not going to do that. I already have it run. And then click Run at the top or press F5. Okay, so after you run, you're going to see the shell and it's going to have the output. So if it's showing 0.0, then check your circuit and then check your code. So in the code, in the while loop, right, we had used the object LDR, and then it would say dot value. So we are displaying, we are going to print the value that the LDR is sensing, right? And we're using light sensor method, which is a class method that was written from the library that we pull from GPIO 0, from light sensor, from that module. Okay. So the way in Python, you can bring in specific pieces from the library using the from and import statement. Okay. For C, C++ is a little bit different. You can only use include. So it's a little bit different for Python. I like it because I don't have to bring in everything. I can bring in part of my library after I install it. Now, if you're using an IDE, you have to also add it to the IDE. So I get 0 when I shine a flashlight. It goes up to 0.98, but when my flashlight has to get close to the sensor, is this work correctly? So you get a 0 to start, and when you shine a flashlight on it, it increases to 0.988. Okay. Yeah, so that's okay. So are you in a dark room, Kevin? Okay. So I think it might be loose in connection somehow, or sometimes photoresistor can also is not that accurate either, but it should be decreasing in the value. Like as you can see right now, I have light in the room, so I'm about 0.7, and then sometime it drops a little lower as far as the waves. But
I have the same thing. I start off at 0.0. I have my best light on, but when I put a flashlight close to the sensor, I do get about the same value you're getting right now.
okay, so you're getting also 0.988.
No, the same values you have. Like I get like 0.
Oh yeah. So in general, you're gonna get about 0.7, 0.6 if you have light in the room.
Yeah, but it starts off at like right now it's 0.0 until I put a flashlight on it.
Yeah. Okay. So the whole point in it is that I wanted to show you that you can use photoresistor for light, right? And then how can you detect it? Because we human have to see some kind of value to know that it works. It's working. Okay, so if you're seeing the values there, then it's working. So if it's inconsistent, it's because it's varied in the light of the room anyway. So right. Any question? Other questions? Okay, good. So when you're ready, you can take a picture of your circuit, and that will be one task complete, one exercise completed. Okay, very easy. Now, if you're using resistor also, Kevin, that might be a little bit different with the 10K ohm. I just want you to know than using capacitor. Okay, because you do have a different value coming from the resistor versus capacitor. Because the capacitor I'm using is 25K, so it is higher than the 10K resistor that was suggested for the assignment, the alternate option. Okay, so keep in mind. Okay, give you guys some time to kind of play with it. So now, if you have to design something, so how can we make this more IoT based, right? What you can do is you can add in some script, and you can have it, you can use like Google API with Twitter, and then have it tweet, like, let's say a value every 2 minutes. So you can put it into a loop, right? So it can tweet like, what kind of light that it's sensing, or, something on that end where and then you would then connect, or you can connect it to a cloud server and be able to pull the data from it or whatnot for industrial use maybe. So there are different ways that we can apply this and make it more internet ready. Okay, but keep in mind that when you're using these type of devices on the IoT end, on the internet, just make sure that you implement security, right? Change up your authentication, use SSH. In order to connect to cloud server, you have to use SSH anyway. So, question. Okay. Let me check the time. All right. Are we okay with this? You have any problem doing this exercise? Yeah, you can use the capacitor from the Arduino kit. If you don't have the capacitor, you can then use the 10K. And the 10K resistor is going to output a little bit different value than what you see on mine. Okay. Okay, so I'm going to stop share. We can also have it print and then, sleep like for like half of a second and then print again instead of printing continuously. But you get the point. It's such a simple script. Next, I'm going to talk about PIR sensors for the second exercise, and that will wrap up the session for today. Again, I will stay on until about 4:15, 4:20. So just to make up some time, if you need help or have questions or something like that, you're welcome to stay on. Okay. All right, let's go over here. Okay, so one picture from the photoresistor exercise. And so this one, exercise B, is on passive infrared sensor, which is, it looks like a little white dome, like the picture is showing, right? And so in the Arduino class, I expanded a little bit more on the lenses and things like that. But just to give you the basic, this sensor sends radiation that we and animals emit. Okay. So around us, we have radiation around us, and so it's pretty low. um, so in general, like, you're not going to be too concerned about, is it cancerous, etc. So a lot of these components are going to be very minimal, right? That's why it's used for um, different purposes in electronics. So it detects changes in how the radiation is emitted, and it would then, when it receives it, if there's significant change, then it would know that you are present, right? So if in a room in general, let's say that we have an empty office and we use the sensor, right? And when a person enter a room, there is a change in radiation. So that's how it's able to know that there's someone there. So often you would see this type of sensor being used for alarm system, right? Or sometimes they would use laser sensor. If you buy like a sensor, full complete sensor kit, you would also find laser sensor there. But this is also good for like security system, for motion detection. In the case where if you wanted to see if there's something that's, like an animal that's in your yard, without using a camera, you can also have it program it where it's going to beep, right? Or it's going to send you notification to your phone, etc., right? And so it would then, once it sends the radiation, the pulse would then be triggered, and that means that it detects there's a being right near it. Okay. um there is some limitation with it. Okay. So the pulse that's going to be emitted when the PIR detects a motion, it would then needs to be amplified. So, and it would use power to be able to amplify that. Okay. Now, when you're looking at the pins, there are 3 pins. You have the VCC, the GND for ground, and then the out. Sometimes they're labeled, sometimes they're not. Okay. The dome, the white dome at the top, it covers what's called the Fresnel lens. And if you actually remove the dome, you can see the lens and also how the pins are labeled underneath. Yeah, they didn't really put the label on the outside for this one, uh, but if you know the position for the pin, right? I'll explain which one is which. Okay. So on the bottom of the PIR, you would see these orange or yellow. They look like little orange yellow screw top, but they are potential meters. And if you turn them or adjust them, you would be able to control the actual sensor sensitivity level. Okay. I put a little arrow there so you can see. So on the right side, that's going to be controlling the sensitivity. On the left side, you would then control the timeout. Okay. So if you want a longer timeout, you would rotate, you would adjust the one on the left. And then if you want how sensitive, low or high sensitivity, you would adjust the one on the right. Okay. So here it says when the timeout is fully turned anti-clockwise. Sorry, my connection. So let me turn off the video real quick. About 2.5 seconds. Is the timeout how long it lasts or how long it is on? So how long in between? Yeah, so in your questions, right? How long it's gonna last before it times out. So here it talks about how you would have about 2.5 seconds. So it's gonna last 2.5 seconds and then it's gonna time out, right? So if if it doesn't detect anything in 2.5 second span, right, by the default configuration or setting, then it's gonna stop. Okay. So how long it's detecting, Cynthia? Okay. So we can make it longer. So if you want, like, you know how some alarm system, it gives you like, you know, a minute, right? If it's gonna sense for like a minute to see if anyone's in the room, okay, like 60 seconds usually. So they would have to adjust that. Okay. Yep, no problem. So if you turn it clockwise, then you would get 250 seconds. So if you go anti-clockwise, you're gonna bring it down to the minimal, which is 2.5 seconds. If you go clockwise fully all the way, then you would have maximum value, which is 250 seconds. Let me end my program on the shell, kill it. Okay. All right. So if you haven't started yet, you are going to need female to female jumper wire on this one. If you don't have female to female jumper wire, you can use a breadboard to adapt it with the male to female jumper wire. If you got some from iMake Innovation Center, then you can use that and plug directly onto your Raspberry Pi without going through the motherboard, without going through the breadboard. So you're gonna need a PIR sensor. You are gonna need Raspberry Pi with power cable and female to female jumper wire. So I normally just follow the basic color schematic. Okay. I just use like dark color for ground, red for power, and then data I can use other color. In this case, I use orange. And it turns out that these are the ones that I tear from my big pack of female to female. So when you connect it, just follow the schematic, the diagram. Okay. So the right one is going to be your ground. That's going to go to the ground connection. That's the dark brown or the black one. And then the middle is going to be your power. I'm sorry. I think that's not right. The VCC is going to be the 5 volt. That's going to be the blue, top left. And then the ground is the bottom. And then the out is going to be their red. Okay, so on this one, they use blue for 5 volt. That's going to be VCC. So the left is the VCC. The middle is your data. Which goes to GPIO 4 or pin number 7. And then your ground. So again, we are going to use the GPIO 0 module or library. You will need to install it if you haven't done so last week. So just to come back, I will upload this after the class. I edited some stuff on here. I you can put in the terminal. You can do sudo app install Python 3 GPIO 0. But before that, make sure that we do sudo app get up or sudo app update, sudo app upgrade. Okay. But if you just did it for the last exercise, you don't have to do it again. So make sure that we install the library, otherwise it doesn't work. So from this library, we are going to use the motion sensor. So for the code, you would see from GPIO 0, we always want to say from which library we are going to import, right? Motion sensor. And for those of you who understands object-oriented programming, it is a superclass. So when you read the script, right? So you are going to bring in the method from that class and to use with the object which you define as PIR. Okay. So in the second line, we declare an object called PIR, and it's gonna use GPIO 4, right, with the method from motion sensor. And in the while loop, let me go to that script. In the while loop, you're gonna see that it has PIR, which is the object, right? And we are going to use another method called wait for motion. And this is a predefined method in the module from the motion sensor module. Okay, so this is not something that you wrote, it's something from the library. So what it's going to do is going to sense, it's going to look for radiation, right? It's going to activate, it's going to trigger the detection for radiation when you use that method. In human, we want to verify that it's doing that, so it's going to print you moved. And then wait for no motion is the second method. This is going to be used with the object to detect, to look for no motion. So it's going to look for low level of radiation at that point. And it's going to be you did not move. And you can output anything in the string here, right? Just to confirm. So like most alarm system, it will say motion detected, right? Or no motion is detected. Now, if we want to make a more of a full system, you want to print this on an LCD screen or an LED screen, right? As a device. So let's say that you build this into a device that you would, like for security, you will put it in a room. You would then 3D print the housing, adapt a screen on it, put the sensor where that, like maybe on top of the device, and cut a hole so that way it can sense with the lens, and then put an LCD screen in the middle, wire it up, build a circuit, right? Have it battery operated or rechargeable battery, and you're done. Okay, so you can definitely build something for your house. Just be creative. Okay, so I will give you a few minutes to work on that, and then I'm gonna plug in my PIR sensor and run my script. And then after you have everything connected, open your idle and then write your script. Okay, so let me go to my Zoom here. I'm gonna unshare this. The file I downloaded does not have the last line. Yeah, I'm sorry. I forgot to. You can add in the print. I will show you that right now. Give me 1 second. I realized that I will have a fixed file uploaded right after the session. I didn't have time because I had a meeting right before this class, so sorry about that. Okay. Um, Here's my PIR script. Okay. So I put PRING. See that? Print. Typo. Let's run that. Okay. So it sends me, and then it says I moved. And you can change the font size for idle under options in the text editor. Okay. Like you can do configure idle. So if it's small and you can't see, or if you want, like, you can also change that here. Highlights, and so on. I put it on 16 so you can see there. Okay, so you can add the last line. Sorry about that. Just add print, you did not move, or you can say motion detected, no motion detected, however you want it to output. Any question? So compare this to microcontroller like Arduino, right? There are a lot of like the pre-process with microcontroller, in that, because we were not using libraries. But if there are libraries that you can use, you can definitely cut back on the programming side quite a bit, right? Why reinventing the wheel when we already have something already pre-made for us to use? And if you want it to be continuous in your script, you should use the while loop, like while true. And you can use a variable, like last time we did while running, right? You can say running is true, and then you can say while true, and then what you want it to execute. So it's going to be an infinite loop. Now, if you wanted to exit, then you have to put in some kind of, condition that it might be able to exit. Or you can also put in conditions here. You can nest an if statement, um, you know, it would wait for motion for how long, and then after that it's gonna then go to sleep and then reactivate, after a certain amount of minutes. And you already, you know we already seen how we can use sleep. We will use it more often, in different areas of Raspberry Pi. So, and for those of you who are interested in doing assembly with Raspberry Pi, your Pi 4 uses ARM. There are simulators that you can download for Raspberry Pi, so you can learn to program ARM or ARM. It's not ARM64, but you can use it. There are tutorials online for ARM. If you're interested in assembly for Arduino, you can use AVR, which, they're pretty similar. Their instruction sets are different because they're different processor. Um, and so on. So when you look at like how this is interpreted, right, it's really instructing the processor to do something for IO. So also learn how to write libraries is going to be also boosting your skills, especially programming skills as well. Right? Super easy, so easy, right? Just like a few lines of script and we're good. So now you have the basic in motion sensor. Any question? Okay, so once you have your circuit and your script working, we can take a picture for assignment submission later. And again, for assignment, we're only going to do 3 out of 4 is the requirement. If you prefer to do all 4, good for you, right? I'm only going to look for at least 3 for the assignments to be able to give you the full grade on it. But, you know, so if you don't have it done right now, that's okay. You have until the rest of the week to do it. Just make sure you do it and submit it before Sunday. The class actually closed on Friday, but I had extended a couple of days. So if you turn everything in on Sunday, I will then be able to wrap up the grade, um, by the following week. So they only give me a few days, like 2 or 3 days to submit your grade. And it's gonna come in like non-credit A, B, C, D, E, F, like anything above a C is a pass, but it's going to be recorded that way. They ask because Web Advisor has already a pass and no pass for credit, and it gets confused. So they had me classified like your grade level for a non-credit pass or no pass. Okay. Any question? I see a chat question. Did you finish? Yes, I did. I posted your grade with Web Advisor, but I don't know. I don't think they said that you might not be able to see it on your end, but I also sent you a badge for the class. If yeah, for those of you who completed the Arduino class. So all you have to do is click accept and then or view. You can print out your batch information or you can have it linked to social media if you need like LinkedIn for job, etc. Okay, so the grade in Canvas is finalized for 833A, and this class will be by next week. Any question? Is there a certificate? Yes, it came from a credible. If you receive an email to your whatever email that you use in Canvas, I think your RCCD email, you would be able to view and print your certificate, or you can use the digital version of it. And on the credible, it specify like what kind of skills you obtain from the course, what course information it is, how it's linked to MVC catalog. I had set all of that up. So let me know if you don't receive it. I can resend it, but it should be in your email. Okay. For 833A if you took it and passed. And for Jose, yes. Check your email. Other questions? Okay, so I'm just gonna take a little bit of time to preview what you're gonna be doing tomorrow. Okay, so today we worked on LDR, which is light dependent resistor or photoresistor. You saw how that worked. You can use capacitor to be able to work with it. And the ones that came with the Arduino kit that I use was 25K. You can also play with different capacitor and see how that would be outputting different value if you have other capacitor. If you didn't have the capacitor, we used the resistor, the 10K ohm, and we were able to kind of see how it would output a value for us to look at to see if light is in the room. Um, and and then the second part, we worked on PIR, which is your passive infrared sensor. This is used for us today is for motion sensor. It's best to detect like, if there's something in the room with radiation. You can also use it to measure distance, but the ultrasonic one is actually a better one to work with for distance as well. Um, so now, for those of you who are interested doing like robots and cars for avoidance, um, like obstacle avoidance type of vehicle, there are several ways that you can do that. You can use a light sensor and have it detect things that are dark and black and white. I have done a little robot kind of car that did that. Or you can use motion sensor and ultrasonic sensor to really look at how far of an obstacle is it, you know, the distance that it's from the obstacle and how can it avoid it. So there are several, there are many different sensors that you can adapt to something like that. Okay. Like something like the iRobot vacuum cleaner. There are ways that we can implement sensor to build something like that. Okay. All right. I'm going to stop sharing this side and then trying to make things work on Zoom here. This will be much better in person, but it's good that we can do remote so many of you can be far away and taking the class together, right? Okay, so tomorrow we are going to look at ultrasonic sensor. If you want to work ahead, you can. That's fine. Okay. This just gives you the very basic in what ultrasonic sensor does. The one that we are going to be using is the HCSRO4, and it has 4 pins. It has a trigger pin, an echo pin, a ground, and a VCC. So VCC is going to be used for power. We normally give these sensor, like the last one, 5 volts or 3.3 and above, right? And then trigger and echo is really used for, for sensing, right? How is it going to detect? So it sends out pulses of ultrasound that's not, we can't hear it. And then it's going to wait for the echo, the bounce back of those waves. So if those waves bounce back, then it knows that there's an object nearby. If there's no bounce back, then there's no object. So a way that it's detecting it is just to send out waves and wait for them to come back. If they come back, that means that they're objects. Okay. And so there are equations and calculations that you can also visit and look at, especially if you want to really implement this for, general daily use. Something that will help the people who cannot see, or, like I said, some robotic based type of systems. Um, so you should take a look at the math calculations for that, and just to make sure that it will be more accurate for the purpose of your device. Okay, so here it gives you a picture. It shows you the angle that will work best. That's going to be here, and then the current that work best with it. right? And the detection range. So the maximum you're gonna have is about 450 centimeter, between 2 to 450 centimeters. So not too far of a distance, something that will be close proximity. Um, Sometimes this ultrasonic sensor is also referred to as proximity sensor, or the other one is also referred to as that. Okay, but this is more on a distance sensor, and the other one is more proximity sensor. So um, what you have is, on tomorrow we're gonna need resistors. So if you don't have 470 ohm resistor and you look at the chart online and you can't find it, you can use something close to it. That's fine. Okay. If you can find like 440, something close to it, it's okay. Um, you are going to need male to female jumper wires, of course, our Pi with power cable, your sensor, a breadboard. We need to adapt this one to the breadboard because we are using resistors with it. Okay. So here it shows you how to connect it and build the circuit. Just when you always check your GPIO pin with your code, okay? Whatever you connect, right? Make sure that it's the right GPIO on in the code. Otherwise, it doesn't work as well. So now on this one, we are bridging the ground because we have multiple resistors here, and then that is going to go to the ground, and Raspberry Pi have several ground connections. So if you don't connect it at the top, you can connect it closer to near the bottom of it, and so on. Okay, so this is what we're going to be doing tomorrow. And on this one, I like for you to build it in stages. So you're going to do a snippet of the script, save the file, run it, test it with your hands, right? Put your hands in front of it, and then see if it works. Then stop it, then add more script, test it again with your hand, and then stop it, and so on. So you wanted to test it in stage. So the first part of this is really to see if it's able to detect some kind of distance. The second part is it going to be, is there something inside that distance range? Is it in range or out of range? And then we would add in parameters to really play with it. So you would have a threshold, and then you would want to modify your distance threshold up to the max. So we gradually would change the value. So when things become out of range, when is it not reachable? So that's what we're testing in this one. Okay, so it kind of give you a little bit of understanding on how it sense, how far something is from it. Okay. Any questions for tomorrow? Okay, so keep in mind that we're going to need those parts. You can work on this earlier if you like. The following exercise to that you can or cannot, you don't have to do it, you just have to do 3 out of 4, but I like for you to experiment with it if you do have time and the equipment that you need is your 16:2 LCD. Um, the the one that they gave you is, it doesn't have integrated circuit, so it has a bunch of pins, um, for the LCD. But if you are able to buy LED and LCD screen on your own, I suggest that you buy one with IC. It has a board that's attached to it, and it would reduce the number of pins that you need to connect, because they can be tremendously difficult if you have a lot of wires, right? Like if you need to build something for your home use, like let's say a retro game system with its own LED screens, you already wire a bunch of stuff into it, and then you have to also wire up your LED. That can be very tedious. So this is a 16:2. That means that it has 16 column and 2 rows. It is very limited. It doesn't have colors. Some of them have colors, some of them don't. Adafruit sells the one that is LED with colors, but they are also 16x2. They're a little bit more. Or you can get like the generic ones like these. Now, in the Arduino class, I mentioned, Ghislaine asked if you can use the foam in the back of it. Yeah, you can use it to cushion, kind of, put it on top of something so it's even, but you can also remove the foam and attach it directly onto your breadboard if you like, or use wires. Okay. So it gives you the chart on the pinout for the LCD. Okay. And so we will work on that tomorrow. We will connect. And then it also goes into the specific on what part or which pin is used for read and write mode. I didn't really get into this with Arduino, and so I just wanted to take this opportunity to present this to you. Yeah, sorry. Okay. Okay, so we'll talk about the pins tomorrow. And then how we're going to connect it to Raspberry Pi. So we are going to need, if you're using female to female, you can also use female to female so you can connect it. But it's because we are using the breadboard, and trim plot in this picture is the potential meter. So I want to check with you. If you don't have potential meter, you can skip this one. You don't have to do it. Okay, but if you do have one, it would look like this, or sometimes they are metal with 3 holes. You can also look up online potential meter. Okay. And this came from the Arduino kit. But if you don't have this, you don't have to do the LCD one. It works best with this because you would then turn the knob to adjust the contrast so you can see what's on the LCD. Just like if you did the Arduino project, you would have something similar. Okay. So potential meter with the LCD. Question. Okay, so just like some of the other projects, when after you hook everything in, and if you see like it's bright and you see no text, just adjust the knob. Okay. Um, and so you should be able to see some kind of text. So there are 2 ways that we can, and you can do the coding part. This is open source project, so I pull it from, so you can get it from someone's site or repo, right? If they have it on GitHub, you can also get it from GitHub. So if it's on a website, you can pull it. So I wanted, just like what we've done before in the first week. So we can pull it from this website, but if you need the script, it's there, and I'll explain the script tomorrow. It's a little longer. All of these are comments at the top. You don't have to type them, but it actually specified the pins. Okay. And then you also need to declare the pins, and so on. Okay, so if you wanted to type out the script, you can. And then you can also change up the string. Okay, any question? Light and easy today. We already did 2 exercises. If you're still working on that, you can keep working. I'm I'm just gonna be on until about 4:20, in case you have questions. If you are done with today's task, please type your name into the chat, and have a good afternoon. I will be on if you have questions or need help. and have a good evening. Video and updated documents will go up shortly. Bye. Oh, you're welcome. Have a good day.